Hi everyone, today we are going to start 1.2, use segments and congruence. We're going to start off with some vocabulary. The first term is postulate or axiom, and a postulate is a rule that is accepted without proof. The next term is coordinate, and a coordinate is the real number that corresponds to a point. And our last term is distance. Distance is the absolute value of the difference of the coordinates. Segment addition postulate. If B is between A and C, then we know that AB plus BC is equal to AC. If you look at your diagram here, you will see that. So if AC is our entire segment, then the bits of AC, which are AB and BC, if you add those two parts together, it will create the entire segment AC. We also know that if AB plus BC is equal to AC, then B is somewhere in between A and C. It's not in the middle, but somewhere in between. For example 2, we're going to apply the segment addition postulate. The cities shown on the map lie approximately in a straight line. Use the given distance to find the distance from Lubbock, Texas to St. Louis, Missouri. So we see that our entire distance would be from endpoint L to endpoint S. I need to figure out what is the distance. Well, if I look at LS, I see that it is made up of LT to TS. So that means that LS is equal to LT plus TS. Well, what is LT equal to? 380, and I see that right here. Plus, what's the difference or the distance from TS? 360. I see that there. If I add those up into my calculator, I end up getting that LS is equal to 740, and I'll say miles. And I'm done. In exercise 3 and 4, use the diagram shown. Number 3. Use the segment addition postulate to find xz. All right, so if I look at my diagram, I see that xz is right here. Well, if I look closely, I see that xz is split into two parts, xy, which is equal to 23, and yz, which is equal to 50. So the segment addition postulate just says, hey, add those up. So 23 plus 50 is equal to 73. Pretty easy. Number 4, in the diagram, WY is equal to 30. So I'm going to label that in my diagram. Can you use the segment addition postulate to find the distance between point W and Z? Explain your reasoning. I'm going to give you guys a second to kind of think about that. Z is right here. Can you use the segment addition postulate to find this distance? Well, the answer is no. Why? Well, that segment doesn't exist. If we look at the picture, I had to actually draw the segment, so it's not there. The segment addition postulate takes a segment and splits it into different parts. If the segment is not there, you can't use the segment addition postulate. Example 3, find the length. Use the diagram to find GH. All right, so I'm looking at my diagram. GH is right here, and I'm going to call that X. So I need to figure out what is X. The entire segment, FH, we know is equal to 36. Well, what are the parts of that entire segment? FG, which is equal to 21, and GH, which is equal to X. So I have 36, the entire segment, is equal to the part 21 plus the other part, X. Now I have an easy problem here. I can get X by itself by subtracting 21 from each side, which means 15 is equal to X. I can double check that by plugging this in, and I know that 21 plus 15 is equal to 36. Next, we're going to talk about equal and congruent. Lengths are equal if you see an equal sign. That means that they are the same length, and it actually will give you a number. So 10 is equal to 10, 20 is equal to 20. When segments are congruent, it pretty much means the same thing, that they are the same length. However, you're never given the exact length, so you don't know how long those segments really are. So it's kind of confusing when to use each. Just kind of remember, equal is when you have the number. 5 is equal to 5. If the situation tells you that the segments are the same length, but you don't know what that length is, we just say that they are congruent. If you mix it up, that's no big deal. All right, example 4. We want to plot J, which is -3, 4, point K, which is 2, 4, L, which is 1, 3, and M, 1, -2, in the coordinate plane. Then we want to determine whether segment JK and LM are congruent. All right, so J is -3, 4. Sorry, it's really hard to draw a dot on this computer. And K, 2, 4. Let's connect those. All right, so what is the length from J to K? We can actually just count. So if I start at dot J, I'm going to go over 1, 2, 3, 4, 5. So segment JK is equal to 5. Once again, I just started at J, went over to K, and that was 5 spaces. We could have also figured this out for JK. If you look at the coordinates, we notice that the Y value does not change. So if I take my X values, I can find the distance by doing the absolute value of the coordinates, of the X coordinates. So for example, the absolute value of 2 minus a -3. So I got that from this 2 and that -3. That equals 5. So if you want to double check, you can do it that way as well. I think it's easier just to count. All right, so now let's plot L and M. So L is 1, 3, 2, 3. That's L. And M is 1, -2. All right, L, M then. Let's count. If I start at L and go down, 1, 2, 3, 4, 5. Or if I want to look at the coordinates, I notice this time my X's are the same, but my Y's are different. So I'm going to do the absolute value of the difference of my Y coordinates, which is -2 minus 3. And I got that from -2 and a +3. Well, -2 minus 3 is a -5, but we know the absolute value of a negative number becomes a positive number. So are these congruent? The answer is yes. They're congruent because they are the same length, and we know they're the same length because they are equal to each other. All right, let's try these similar problems, just like the last two. So for number 5, use the diagram at the right to find WX. So we're going to call that X. All right, I'm going to give you a second. You're going to have to answer the question, what is the solution for X? All right, so to solve for this, I'm going to have 144 is equal to 37 plus x. Once again, 144 is the entire segment, and these two are the parts. So to find the whole segment, we just have to add the parts together. So to get x by itself, I'm going to subtract 37, subtract 37. Those cancel, and I'm left with 107 is equal to x. Hopefully that's what you got. Plot the points A, which is -2, 4, B, which is 3, 4, and C, 0, 2, and D, 0, -2 in the coordinate plane. Then determine whether A, B, and C, D are congruent. Try this one on your own and tell me, are they congruent? Yes or no? Hopefully you got the answer that it's no, they are not congruent, and this is why. So A is -2, 4. I'm going to call that A. B is 3, 4. There's my segment. The length of this segment is 5. Once again, just count from A to B. C is 0, 2. And D is 0, -2. So this is C, this is D. And if you count those spaces, it's 4. So is 5 equal to 4? No, it's not. So they're not congruent. For this next problem, we're going to use algebra. M is a point between L and N. Use the given information to find LM and MN. I'm going to scroll down a little bit. I already have no picture here, which means I'm going to need to draw a picture. All right, so I have draw my segment. I'm going to call this guy L. I'm going to call this guy M. And I know that, oh, I'm sorry. That is an N, not an M, because M is somewhere in between. And I will put M right here. Not in the middle, just somewhere in between L and N. All right, so LM is equal to 2x plus 4. Scroll down. I know that MN is equal to x plus 6. And LN, which is the entire segment here, is equal to 31. All right, let's set up our equation. What is the entire segment? That is LN. And what is LN equal to? 31. What are my parts? Well, one part is LM, which LM is equal to 2x plus 4. The other part is MN, which is equal to x plus 6. So this is a little bit harder because now I have two equations that I'm combining together. But that's okay, because I'm just going to combine my like terms. So I have an x here and an x here, and I have a constant here and a constant here. So 2x plus 1x is 3x, and 4 plus 6 is 10. So I have 31 is equal to 3x plus 10. Now I can just solve for x. First thing I need to do is, subtract 10 from each side. Those cancel. End up getting 21 is equal to 3x. Divide by 3. Divide by 3, which means 7 is equal to x. Now the problem, if I scroll back up, it did ask what we want to find LM and MN, which means we want to find the lengths of them. So if I know what x is, how can I figure out what the lengths are of my two segments? Well, I'm just going to plug x into the equation. So for LM, I'm going to do 2 times 7 plus 4. And if I plug that in my calculator, I end up getting 18. For MN, I'm going to do the same thing. I'm going to plug in 7 for x. So 7 plus 6 is equal to 13. If I add 18 and 13 together, do I get 31? I do. So I know I have the correct answer. All right, let's practice this again. So using algebra, B is a point in between AC. So right away I'm going to draw out my picture. So here's A, here is C. I'm going to put our point B somewhere in between. Use the given information to find AB and BC. So I know AB is x plus 3. I see that BC is 3x plus 1, and AC is equal to 20. All right, so let's set up our equation. 20, because 20 is the entire segment AC, is equal to AB. Well, AB is equal to x plus 3 plus my other segment, BC. Well, BC is equal to 3x plus 1. Combine like terms, 1x plus 3x is 4x. 3 plus 1 is 4. So 20 is equal to 4x plus 4. I need to get x by itself, so I'm going to subtract 4. Those cancel. So 16 is equal to 4x, which means 4 is equal to x. All right, I need to plug my x back into my segment equations. So AB then is going to equal 4 plus 3, which is equal to 7. BC is going to be 3 times 4 plus 1. That is equal to 13. Is 7 plus 13 equal to 20? It is. And I'm done. Here's our challenge problem. The figure shows M between A and B. We have a lot of different things we're going to need to solve here. We want to first solve for x, find the length of AM, find the length of NB, find the length of AB, and then finally, what's the coordinate of that point that's in between A and B? All right, so let's look at our figure. What's different from this one compared to our last two problems is that we don't know this length. All the other ones have told us what that length is, but what it does tell us is that A is located on -16 on a coordinate grid, and B is located on 33 on the coordinate grid. All right, so I want you to think about a coordinate grid. So we have our negative numbers, we have 0, and then all of our positive numbers. So if I start at -16, and I move over to the right to try to get to 0, how many spaces did I just move over? A positive 16. So now if I'm at 0, and I need to go to 33, how many spaces am I going to move over? 33. So I need to add 16 and 33 together. That gives me 49. So my distance on a coordinate grid from A to B is 49. All right, so that's going to be the beginning of this problem. I'm going to scroll down again. So AM is 3x, MB is 4x. So I'm going to have 49 is equal to 3x plus 4x. Let's solve for x. Well, 49 is equal to 3x plus 4x is 7x. So that means that 7 is equal to x. So that's going to go here, 7. All right, now I need to find my different parts. AM, I just have to plug in 7 for x. So 3 times 7, that's going to be 21. MB, once again, I just have to plug in 7 for x. So 4 times 7, that's 28. So here is 28. And find AB. Well, we already found AB. That was the entire segment. That was 49. Next, I need to find what is the coordinate of M. All right. What is that coordinate? Well, if A is at -16, and I know AM is equal to 21, to figure out what M is, I just need to add those together. So -16 plus 21, because I'm moving over 21 spaces on the coordinate grid, that is going to equal 5. So M is at 5. And I am done.